Google Meet decides to have its power. um, all right, so I'm going to share my screen and I am going to briefly go over the setup for the tutorials in case you haven't been able to get it working or in case you didn't get a chance to look at the document. I'm also going to go over a little bit about the framework that we'll be using in the tutorials, the rules of what you can use it for, and that sort of thing. So can you all see my screen right now? You should be able to see Canvas.
Yep.
Yeah, okay, great. So if you go into the Home tab or the Modules tab, you'll see the main area where we have all of the lecture slides and all that stuff. My screen will look a bit different in yours. I'll just pop it into student view. This will be what you see. And if you go to the lecture and tutorial demo setup guide, hopefully you've already gone through this document. If you haven't, this is definitely something you want to have saved and you want to read through and go over when you have some time. For today, what you'll need is the tutorial repository. So that's linked on the second page here. And if you go to that link, you'll see a GitHub repository. You'll be sharing this repository between this course and your graphics course, 1350, with Dr. Patsy and Sean as your TA. So we're going to have all of the tutorial code in one place for both courses. We're just going to be using kind of different frameworks so that we're not stepping on each other's toes. So there's some README stuff here that's helpful for you if you want to make your own projects in the framework, for example, for your assignments in this course, and I believe for graphics as well. So you'll want to read through that if you have time, when you're actually setting up your own projects, if you're choosing to use this framework. But in the meantime, basically just copy this link. And then I'm going to go over to my source control software of choice. I use SourceTree. You can use whatever you want. If you are using SourceTree to add a new repository, what you're going to do is click the little plus icon up here. And then I'm going to hit the clone button to say that I want to clone, make a copy of a repository from the web. So I'm going to paste that URL in where it says source path or URL. And then here where it says destination path, I'm going to browse to a folder where I want to save it. So I'm just going to go to the folder that I keep for this course. I'm going to make a new folder called tutorial demo or something like that. You can browse to whatever folder you want if you haven't already cloned the repository. And then you select that. And then you just hit clone. And it'll take probably a minute because it's just pulling code and a couple of assets that are on the repository and things like that. And then SourceTree or whatever client you're using will probably redirect to a view of the history. So you'll be able to see all of the commits. In other words, the changes that Sean and myself have made. Atia will probably make some changes to this repo as well. And this is kind of the copy that you'll be using that has all of the tutorial code and everything like that. So whenever there's new changes to the repository, you'll want to hit the pull button up here. If you're using SourceTree, if you're using a different client, there's probably also a pull button. It might just be located somewhere else, and you'll want to hit OK. And then if I had any changes to pull, they'd be pulled in. You might need to double click at the top to update to the current change that you've just pulled, but it will probably do that automatically. You won't be able to commit and push to this repository since this one is locked for access to the TAs and professors. But if you want, when you're working on assignments or something like that, what you can do is kind of download a copy of the repository, and then you can make your own repository starting from a copy of this one if you want to use source control for your assignments, which I personally recommend if you're comfortable with it. So if you go back to the GitHub page, you can also just click here, and then you can download a zip if you want to just have a copy on your computer that isn't linked to GitHub. So now that I have this downloaded, what I'm going to do is I'm going to go to Windows File Explorer, and I'm going to browse to the location where I told SourceTree to clone the repository. So I put it in my computer animation folder, tutorial demo. And if you go inside there, you'll see all of this that was downloaded from the repository. We have something called Premake, which Sean set up, which is going to build your Visual Studio projects for you. So after you've downloaded this and after you've pulled, you'll want to hit premakebuild.bat. and it'll pop up a console window. It'll do a bunch of stuff on its own, and then you just hit whatever you want to close it, doesn't matter. And then you'll see that an SLN file appeared. That's a Visual Studio solution, as you probably know. So you can just double click that. And I have Visual Studio 2019 set up as the default to open Visual Studio solution files, and that's what we'll be using in this course as well. So unless you really, really, really want to use something else, I strongly recommend that you use Visual Studio 2019, because we will not be able to troubleshoot any other IDE or any other version of Visual Studio. We just have to stick to kind of what we're recommending for the course. So if you go into the solution here, if you poke around at the side, you'll see all these dependencies, which are, these are external libraries that we use for this. And if you open modules, this will be the more internal stuff that we've set up, which I'll go over in a minute. And you don't really need to care about those. You just care about the samples folder here. And you might also have a projects folder if you have your own assignments. And eventually you'll have a samples folder for your graphics course as well. So what you want to do is, just to start, to make sure that OpenGL is working on your computer and everything, you'll want to expand the KnowU sample using the KnowU framework, which is the framework that we created for this course. Yes, it is in fact a result of an ongoing KnowU war between Atia and myself. Something really helpful as well, when you have your project selected, hit this little icon up here in the Solution Explorer that says Show All Files. That will make it so that you can actually see the folder structure as it would be in Windows Explorer. If you're adding your own code files in Visual Studio, if you have this Show All Files enabled, it'll just make it easier to make sure you're adding those files in the right place, and you don't constantly have to go browsing when you're adding a new file in Visual Studio. But you don't have to worry about that for today. So I'm just going to double click the source file so that I can see it while I run this. You don't have to. One thing you are going to have to do is that the project is going to probably default to having GLFW as a startup project. See how it's bold like that? GLFW is actually just a support library we're using. It's not something you can run. It's a lib. It's not an executable. It's not an application. So Visual Studio builds that and it gets used in your projects, but it's not something you can actually run. So if you leave that as a startup project, you'll get this really weird error, which I will show you right now. And you'll probably think, oh, what the heck is happening? What does this mean? This means that you have the wrong project set up to start. You can't run a library file. It's not an executable, so that's why that'll happen. So if you get that, the way to fix that is to right-click on one of the actual runnable projects that we have. So I'm going to do the sample project. And when I right-click it, there's this whole list of stuff here. You want to go to Set as Startup Project. And a quick way to recognize that is the little gear that's off to the left. So you hit Set a Startup Project, and then if I hit Run, and I can either click the play button up here, Local Windows Debugger, or I can just hit F5 on my keyboard, which is what I usually do because I'm lazy. You'll see that it'll start to build everything. It will take a while the first time you do this, since it's also building all of the dependencies. It'll be much quicker on subsequent runs because it only has to rebuild the code that you've written. But the first time you launch this, it will take a while, and that is normal. It's also normal for you to get a couple of little errors coming from the dependencies. You guys don't have to worry about that. Can I go over how to set the startup project again? Yes, absolutely. I will in just a moment. How do you open it? Taylor, do you mean the Visual Studio file or running the project? The Visual Studio, right. So I'm just going to, this is what you should see when you run the project successfully, and you can just hit Escape to close it. So how you open Visual Studio is once you've run that once you've double-clicked the pre-make build script, an SLN file will appear in Windows Explorer. So you just double-click that, and it should open in Visual Studio 2019. So how you set the startup project, again, I'll switch over to the tutorial startup project right now, and I suggest you all do that as well, since that's the project that we're going to be using in this tutorial. I'm sorry I keep looking over to the side. I've got you guys on a side monitor right now, and I'm just kind of instinctively looking over at your faces. So what you will do is go here under the samples category. We're going to select the week 2 tutorial LERP project. I'm going to right click it, and then I'm going to go down here to set as startup project next to the little gear, and I'm going to hit this. And then if we hit run, this one will look different. This is just going to be a black window because that's what we're starting from today. Atia is going to show you guys how to get that black window from a black window into a really cool, well, you know what, I'm not going to spoil it. She's going to show you some cool stuff. Okay, questions from chat. If you don't have a framework for GDW, that doesn't matter for the tutorials. Everyone is pulling Otter. Everyone is pulling Otter. It's a public repository. It doesn't matter what your GDW situation is. Absolutely everyone is pulling this one repository. If you only have no U in samples, then that's because you haven't pulled. Because we added the week 2 tutorial project basically a couple days ago, and then the title was updated this morning. So once you pull, you're going to need to browse to the folder where you have everything saved, and before you open Visual Studio, you're going to rerun that pre-make build script again. You're just going to double click it, and that'll be that. So yeah, before every tutorial, you do have to run that to update the solution. And I strongly recommend that you close Visual Studio if it's open before you do that. Otherwise, Visual Studio is going to like get up in your face and say, oh, this project has been changed on disk. Do you want to reload it? Make sure that you quit Visual Studio first just to avoid that from happening, because it can be confusing if you're not used to dealing with Visual Studio. I see we have something posted in Discord. I'll try and troubleshoot that. Taylor, your Solution Explorer panel is set to Team Explorer instead of Solution Explorer. So this panel here, you have the Team Explorer open. If your screen looks like this for anyone, you'll want to click on Solution Explorer here, and that'll bring you to this. And then from here, you can browse to the project you want to use, hit that Show All Files button, and then I'll open the source code for today's tutorial, and I'm just going to pin that using the little pin here so that it stays in my view. So if your view looks weird, that would be why. You don't have the auto build thing. If F5 isn't working for you, your keyboard shortcuts might not be set up properly, and you can just hit the play button up there. Same thing. And yeah, no worries, Taylor. Visual Studio can be really annoying. Okay, so once you have all of this set up, then I'm just going to go over something really quick just to kind of familiarize you with the framework. If you have questions about this, I will answer more questions about the framework later, but I want to send things over to Atia soon to get the tutorial started. So I'm going to really quickly go over what I mean by the No U framework and that kind of thing. So if you look in the modules category, one of the modules is called No U. That is the framework that we wrote specifically for this class. And we will be using it in the tutorials. You're also allowed to use this framework and the No U namespace for your assignments for this class. Unfortunately, you're not allowed to use it for GDW. It's not my rule. It's just a rule. However, I have no problem at all with you referencing this code if you want to dig into how it works for when you are writing your own framework. And if you have any questions about it, you can just ask me and I will be happy to explain any of it. It is heavily commented as well. So if you want to browse through that on your own time when you're working on your GDW, it might be a helpful reference for you. So basically what it does is it's a really simple framework that does some basic graphic stuff with OpenGL, and it's a lightweight wrapper, if you want to call it that, for the entity component library that we have as a dependency, which is called ENTT, which you can use in your GDW projects if you want. You just can't use any of the code that's from the No U project. So, for example, if I go to the entity header here inside No U, you can see that there's a bunch of comments to kind of tell you what's going on here. So if you want to reference this code, you can. For those of you, if you don't remember, an entity component system is a really common pattern for how a game engine is designed. essentially entities are things and components are scripts that you attach to things to make them do specific stuff. So like you might have an entity that represents your main character, and then that entity might have a component that's like a 3D model, and then another component that's an animator, and then another component that lets you move it with the arrow keys, that sort of thing. So this is just a really basic wrapper on that that lets you create entities and then add components of custom types to them. And Atia is going to explain a little bit more about this by example. Since it's kind of hard to explain this without a code example, you'll be looking at that at a really simple level today when you actually look at the tutorial. So again, just to be clear so that I don't accidentally make any of the other profs really angry with me, you're not allowed to use the code from KnowU in your GDW projects, but you can reference it and learn from it. And you are allowed to use all of the code that's in KnowU for your assignments for this class. You cannot use the code that we'll write during the tutorials. You can't just copy paste it as part of your assignments, but all of this code that's in the KnowU module, in the KnowU namespace, you can use that in your assignments. If you have any questions about that, let me know. That might be a little confusing if you're not used to managing multiple code projects. Was the framework you used in first year OpenGL? I think it was based on OpenGL, yes. You can use Otter, but not KnowU. Yeah, basically the rule is that you can use anything in the dependencies folder, but not in the modules folder. Like you can use fmod actually, but you can't use KnowU, you can't use toolkit, and sample module is just it's like blank. It's there just to show you what a new module would look like. And yeah, if you don't have any folders showing up or anything like that, you're going to want to hit that show all files again. Okay, so anyways, that's about it for startup. I'll take a few minutes to answer questions before I hand this over to Atia, probably at about 3:30. The screenshot in Discord. That's strange. That's not even something that this is dependent on. I'm probably going to have to look at this outside of the tutorial time, Kimberly. I'm not 100% sure what that's for. I think that might be something specific to your Visual Studio installation, to be honest. You don't have a show all button, right? The show all button's kind of hidden. It'll only be visible if the project is selected and if you haven't already shown all. It's very frustrating in Visual Studio. The show all button is here. So it might be that you already hit it, or that you might have already hit the button. Honestly, I for individual errors when you're trying to run things, shoot me a direct message on Discord or in the channel, and I'm going to try and help people while Atia gets to the main meat of the tutorial for everyone that has been able to get this set up. The nature of online classes and everyone using different laptops is that it's just going to take kind of long for us to be able to solve everyone's issues at the start. So I'm going to hand things over to Atia, and she's going to get started with the main tutorial. And for anyone that's having issues, this is being recorded, so you will be able to catch up after the fact. And I will try and help troubleshoot your issues in Discord. Okay, so Atia, whenever you're ready, feel free to get started. I'm just going to mute myself and turn off my camera and see if I can help those with Visual Studio issues and such in the Discord.
Okay, got it. Hello, everyone. I'm going to take over from here. I'll quickly share my screen. There we go. Yep, okay, perfect. Hi, okay, so do you guys see everything? Yeah, okay, perfect. All right. So I did notice one person saying that they get an error every time they try to run it. Make sure that you right-click the week 2 tutorial project and select set as startup project. And that way, when you run it, you shouldn't get any errors. Otherwise, if you're still running into errors or if there's something weird going on, feel free to message Samantha because she'll be handling the technical issues while I go over the tutorial itself. Okay, so Okay, got it. I'll admit this is my very first time teaching so many people how to code, so am I a little nervous? Yeah, but I think this will go well. Fingers crossed. Hopefully nothing will implode. I'm going to start off by writing the LERP function, and also if I'm ever going too fast or anything like that, feel free to let me know and I'll slow down. But yeah, so I'm going to start off by writing the LERP function, and this does harken back to what Samantha talked about during the lecture, because she actually showed you how to write one, and she also showed you how to make a template function. So I'm going to quickly write the syntax for that. It's template type name T, and template functions are actually really, really handy, and I'll explain why in a sec. So as covered in the lecture, we'll be taking in 3 parameters: the original point, the ending point, and one, and we're also going to take in a float for the t variable. So the reason why template functions are so handy, just to reiterate, is let's just say that I want to LERP between 2 vec3s, right? So I could just write this function as glm vec3 to return a vec3, and I can take in, 2 vec3 variables and then the float. I could do that. However, then let's just say that I want to LERP between 2 floats or something like that. Then I would have to rewrite that entire function, just changing small bits of it so that it can account for floats. That can be really tedious. It can cause a lot of repetition. Instead of doing that, it's a lot easier to just use a generic type. So by making the return type generic and by taking in 2 generic variables, I can just, LERP whatever data type I want, and I'm not gonna run into issues or anything like that. And you guys will see that in action. Before I continue, does anyone want to tell me what the LERP formula is, specifically the code version? And you can say it in chat too, because I'll be checking that. Does anyone happen to remember? So specifically the code version, and I'll type that out real quick here, but it's return 1 minus t times the first point plus t times the endpoint. So this is our LERP function here, and we're going to be using that very soon. Real quick, I'm just going to run this, make sure nothing broke. And yeah, we see a black screen. That's perfect. That means nothing has gone wrong yet. Now over here, we see that, this here is initializing the window, setting the background color. This framework also comes with its own shaders. They're being loaded in here, and a shader program is being created with those shaders here. Now, for this tutorial, I really want us to load in a duck model and do some fun shenanigans with that. So I'm going to show you guys how to do that. First things first, if you look in the file explorer, and if you go to where the project is, under res, there's a duck folder. And if you go in there, you'll see a duck GLTF file along with a PNG that has a texture. Now, GLTF files, they're like OBJ, except they're really handy because they store animation data and things like that as well. And they're what we're going to be using for this class. So in order to load in the mesh within that GLTF file, we first create a mesh object. Again, something available through the KnowU framework, and I'm just going to call it duck mesh. And then one of the functions that's available for us to use is GLTF load mesh, and all we got to do is pass in the file path. So this is relative to where the res folder is, so we don't need to write res slash blah blah blah. We can just write duck because it's in the duck folder, and then duck.gltf, and then we just need to pass in the corresponding mesh. So here we go, duck mesh. Okay, that's all we got to do for the mesh. Next, we got to worry about the texture. So for this, we simply create a texture 2D object. I'm going to call it duck text. And we just need to initialize it. So equals texture 2D. And like before, we just pass in the file path, and it was called duckcm. So slash duckcm png. Okay. So there's that. We're not done yet, because now that we have the texture, we need to create a material, because all these different objects have materials attached to them. If you've worked with Unity at all, this part may seem kind of similar, because in Unity, you put materials on the different objects to make them look different ways. So I'm going to create a duck material. I'm just going to call it duck mat. And for this, if you actually go to the class, you'll see that it takes in a shader program within its constructor. And that's what we're going to do here. Since it's already created, we just pass prog text lit. And then after creating the material object, we just need to add our texture to it. So it's duckmat.add texture. And it's going to be an albedo texture, duck text. Okay, so that's that. Is everyone following along so far? Yes, I assume so. Perfect. Now, if we run this, we'll see that in
Oh,
just a second.
I think a couple people are saying that we might need to wait a sec.
Okay, got it.
You might also want to zoom in slightly on the text. I think depending on how intermittent the internet is, the recording might be a little small on text. I think
You're
that's
absolutely
probably
right.
better.
Okay. Is this good? Should I zoom in more?
Does anybody need it zoomed in more?
Permission was canceled. That's weird. Seems good. No, it's not needed, but I missed that part. So the duck file, it should already be there in the repo. It is under, so if you go to where your Reaper is, under samples, that's where all the projects are. You go here to week 2, you go to res. Res is where all the meshes, textures, so on and so forth are located. Now I'm gonna continue. If you have issues or anything like that, remember to post it in the Discord, and Samantha will be there and she'll help you out. But if you've been following along at this stage, you should still be seeing a black screen, because even though we've loaded in the duck mesh and the duck texture, there's still more steps we need to go through before it will actually render to the screen. And one of those steps being actually setting up the camera and all of that, because obviously we would need that. And before I set up the camera, I want to explain, Samantha already went through what an entity component system is, and just to reiterate, in our scene, everything, all the different objects in it are entities. And what this means is some of them will have unique components added to them, but also there are some common variables that they all share, such as the transform, which you'll see in a second. And again, if you are at all familiar with Unity, Unity does use an entity component system. So in order to create our camera, I'm going to create an entity, camera entity, equals entity create. And that's pretty much it. That's all we got to do to create the entity. Now, because this is a camera object, we are going to have to add a camera component to it. So the syntax is a little weird, so I'll just show you guys what it looks like. So first we declare it as like an auto variable. It's like a shorthand. So it's like it automatically detects what you're trying to set the variable to, and it's also going to be a reference. So I'm just going to call this cam. And when you're trying to add components to entities, this is what it looks like. So you write the entity name, then you write add, and I'm trying to add a camera object, which is one of the know you classes. So it's this right here, see camera. And then if we actually go to the class, we can see that it takes in an entity in its constructor, and that entity acts as its owner. So what we're going to do is we're going to pass in cam entity. And yeah, so whenever we're adding components to our entities, this is what it looks like. And having set this up, if we are to go back to that camera class, we can see that it has all the different properties that a camera needs. Basically, lots of gross math stuff and like the perspective matrices and all that kind of stuff. And we need to set that as well. So I'm going to write cam perspective, and I'm going to set it to 61.1 and 100. So I've set the perspective, I've set up the entity. Now I'm also going to set the transform. And like I said before, this is one of those things that's going to be on all of the entities. So I'm going to write cam entity dot transform. And here you can see the different values we can play around with. So there's a position, rotation, scale. I'm going to worry about the position, and I'm just going to set it to CLM spec 3, 0F. So that is the transform that I've just set. And hopefully everyone is following along. Is anyone behind? Okay. So if I'm ever going too fast, make sure to let me know. You can even turn on the mic to tell me. But again, if we try running what we have, and hopefully there won't be errors. Yeah, we still see a black screen because we have created the camera entity and we did that properly. But now we need to create an entity that represents our duck. So I'm going to do that right now. And it's a very similar process. So I write entity, duck entity equals entity create. And I'm not going to set its transform quite yet. Instead, I'm going to add its mesh render component, because in order to get it to actually show up on screen and to draw it, it needs a mesh renderer. So again, very similar to before, duck entity.add, see mesh renderer. And if we look at this constructor, it needs the entity that acts as its owner, and it also needs a mesh and a material. So I'm going to pass that information there, and it's just the variables that we created before. So it takes in the duck entity, the duck mesh, and the duck mat. Now I will be setting its transform and all of that in just a sec. But before that, I want to see what it looks like when I'm just, when I've just loaded it in and before I make any changes to it. Now, running this again, we're still not going to see anything. And the reason why is because now that we've actually created it, for all the different entities and things like that, typically you need to update them and you need to draw them for them to actually show up in the scene. So this is our main game loop, and app frame rate that, yeah.
You said that we should be able to see a black screen, but I'm still getting the moving ducks from earlier.
To anyone who's getting that, you need to make sure that you've set the tutorial project as your startup project and not no use sample. So
Yep.
make sure that you right click the tutorial and then hit set as startup project.
Okay. Thank you.
Okay. No worries.
Okay, so I actually want to quickly see what the duck entity looks like before making any changes to it. And in order to do so, if I just ran it as is, I wouldn't be seeing anything because we actually need to update the objects we have in our scene, and we also need to draw them. So first things first, we do need to update our camera. So that looks like cam entity. And then we get the camera component and we update it. Then we need to recompute the global matrix of the duck entity. So basically, we will be modifying the transform of this duck. Obviously, it's a LERP tutorial, I'm sure you guys probably guessed. But because we're making these local changes, the global matrix has to be updated to reflect the changes that we made. So I'm going to call duck entity transform and recompute global. And lastly, so that it actually shows up on screen, you need to write duck entity dot, and I get the mesh render, and then I call the draw function. Okay. So having done all that, if I didn't do anything wrong, hopefully it will show up on screen. And there. So as you guys can see, this clearly looks very janky and it is not ideal. Clearly the duck is too big and we need to probably move it around, maybe even rotate it. And chances are, if you're getting models or anything like that from the internet, a lot of times you're going to have to like mess with its scale and all these other properties, or else it won't look right. So in this case, I'm going to start off by making its scale much smaller because it looked like it was way too big.
Could you quickly go back to that piece of code for updating the camera?
This right here?
Yeah, just that last part that says the seat. Yeah, thank you.
Okay. I'll wait here for a sec and then I'll move back up. Just tell me when you're good.
I'm good, but I still think there's some people who need it too.
Okay.
People were just saying it in chat.
Yeah, I can't see the chat right now, which is a bit of a hassle. But yeah, I'll just wait for a minute, and if you guys need more time to write this, let me know. So in just a second, I will continue. I'm just trying to update my setup so that I can actually see what you guys are saying. And okay, so I should be able. Okay, nice. I see a lot of you guys are caught up. That is perfect. And now I can see all your comments. That's great. So I am going to push this after, so you guys will be able to see all the completed code. And yeah, now if any of you guys are having into trouble or running into trouble or are not able to keep up, I'll be able to see. But I'm just going to continue going for now. So the duck entity is clearly too big and we'll probably need to update its transform and those kinds of variables. And I'm just going to start doing that now. So I'm going to start off with its scale and I'm going to make it a lot smaller. By default, it's set to like 1. So I'll try 0, 5. I'm setting the scale to 0 0.05. And let's see how that looks. Oh, my bad. I have to set it equal to GLM vec3. Okay. So it's still a little too big. So clearly we need to make it a bit smaller. So I'm just going to make it a little bit smaller by changing the 0 0.05 to 0 0.005. Yeah, that's much better. We can see our duck in all of its glory. Now, for the purposes of this tutorial, I want to move the duck down a little bit. So I'm going to write duck entity dot transform dot position equals vec3, and I'll make the position 0, -1, and 0. And I think what I'll probably also do is adjust its rotation. Transform dot rotation, and setting its rotation isn't quite as simple because it's a quaternion, but I'll show you guys how to set it up. So we call GLM angle axis, and then the first parameter it takes in is a radian, so GLM radians, and I'll set that to -30. And then GLM vec3, 0.0, 1, 0.0 again. Now, if I run this, this is exactly how I want the duck. It's at a good rotation and I can see it perfectly and everything. So we can continue on with the tutorial and actually start messing with the different properties of the duck. But before I do so, stay on the code, please. Okay, I'll wait for you guys to finish typing this out. So someone is saying that angle axis isn't working for them. Did you write it out exactly like this? Yeah, make sure to use GLM when you're writing all these things out. Yeah, it could be that. When you guys are ready to continue, just let me know in chat. Okay, great. I'm glad you fixed it. Which is the line that loads the duck? So, do you mean over here where we're loading in the model and the texture? Renders the duck, yeah. So that's within the loop, and it's duck entity dot get cmesh render dot draw. If that's good, let me know. And if you guys are all caught up, let me know and I'll continue the tutorial. You still don't see a duck? Did you make sure to update the camera as well? Oof. Good luck, Gary. Yeah. Oh, the line that Jackson is referring to, that adds the mesh renderer to the duck. And then once you do that, you go down to this while loop and you call the draw function. Okay, if it's too big, just write down what I have here because this is me modifying the duck's transform so that it fits nicely onto our window. So that prog text lit sets up the shader program. If it's getting, yeah, you can message Samantha and send a screenshot. Okay, so I'll keep this on the screen for anyone who needs it, and I'll start doing the next part of our tutorial, and this will still be visible if any of you guys need it. But now that we have our duck entity and our camera entity, and now that it's actually drawing on the screen and that we can see everything, we will start actually lerping it. And this is very similar to what Samantha did in Unity with the Pac-Man holding the gun, but I will also be doing it a little bit differently. And again, because of C++, it'll be different syntax and all of that. Anyways, so I'm going to start off. Oh, he was holding a gun and a cereal, according to Samantha. But anyways, I'll start off by creating variables that store the, I want to move the duck along the y-axis and I want to make it lerp on the y-axis. So I'll create variables that store the original position and the new position. So variables for lerping position. And I'm going to create a vec3 and call it original position. GLM vec3, and the original position is 0f, -1, and 0. And I also want to create a variable for the new position. So that will be, how about, I want it moving up. So I'll write GLM vec3, 0.0f. And since all these values are the same, honestly, I can just write it as this and it'll be the same thing. Why is this giving me an error? Oh, oops. There we go. Okay. So I have a variable for the original position and a variable for the new position. After writing that out, I also need to create a timer. Again, similar to what Samantha did. So I'm going to create a float for the timer. I'm going to call it pause timer. And I'll just set that to 0. And I'm also going to create a float for the time limit. So for now, I'll just set that to 2. Does everyone have that? Yeah, you'll be able to rewatch later, and you'll also be able to pull the finished code once I have that up. I guess for now you can just follow along. So now that we have this, we can move down here to where the loop is. And as we can see, delta time is being set here. So what we can do, oh, go back? Okay, sure. If you pull the finished code, it can overwrite what you've done if it's different from what I have here. If that makes any sense. Okay. So I'll keep this on the screen and I'll start typing the next little bit if most people are caught up. But again, if you need more time, make sure to let me know. So I'm gonna start off by incrementing the timer. So since we already have delta time, I'm just gonna write pause timer plus equals delta time. And then I'm going to check to see if this timer goes above our time limit. And if that happens, I want to reset it to 0. If pause timer greater than or equal to pause time limit, I'm going to set it to 0. Once that's done, oh, yeah, you're right. Oops. Anyways, now that that's done, we just need to calculate our t-value. So I'm going to call it float t pause. And who can tell me how we would calculate it based off of what you learned in class? Does anyone have any guesses? You can type it in chat. Okay, so based off of what was covered in class. All we have to do is write pause timer divided by pause time limit. And yeah, that's all there is to it. This will give us a value between 0 and 1. And now that we have that, we can go ahead and LERP the Y value of the duck. So what I'm going to do is write duck entity that transform that m pause. And now I can use the LERP function that we wrote earlier. So LERP original position with the new position being the endpoint, and I pass the t value. Oh. Okay. So is everyone caught up? I'm assuming so, since I don't see anything in the chat. And now when we run this, I am noticing that the frame rate is pretty bad. I think that's just because of Google Meet, because it's running smoothly on my end. But you should have something like this. Someone is asking where the original position is. It's right over here before the loop itself. I just declared the original position and the new position. See, someone wants to see someone wants to see the LERP code again. Do you mean the function? Yeah, feel free to ask questions afterwards if you're still confused about anything. Where did I write T pause? That's right over, that is right over here. So it's after incrementing the timer. Okay, so original position, that is over here, right before the loop. Yeah, so if anyone else has any questions, make sure to let me know. But now that we have this, when I run it, the duck keeps going up and then it restarts, but I don't really want it to do that. I want it to go up, reach the top, and then go back down. So someone wants to see the code at the bottom. Do you mean this code? If it's not moving for you, make sure to call the recompute global function on the duck entity. And also make sure that you're also calling the LERP function. Does anyone still need to see the LERP function at the very top, or are you guys good? LERP function? Oh. Still not moving. Did you set the new position correctly as well? It's over here. If you're still running into issues, yeah, you can message Samantha and show her what your code looks like and she'll be able to help out. Nice. Yeah, so that's what I'm gonna do right now. I'm gonna make it go back and forth. And I'm doing it a little bit differently than how Samantha did it in class. So I am going to start off the same. I'm going to declare a Boolean, and that's what I'll be using to determine whether it's going up or whether it's going down. So I'm going to create a Boolean, and I'm just going to call it ducky go places. And I'll set that to true. So when it's true, the duck is going up. When it's false, the duck is going down. And then after declaring that Boolean, if I scroll down here, I'm going to write if ducky go places, then the duck entity will lerp like this. Or if it's more clear to people, if ducky go places equals true. Otherwise, if it equals false, equals false, then I'm just gonna copy paste this here, and I'm gonna make it so that it lerps from the new position to the original position. So it looks like this. And once I have that, they'll keep this up on screen longer if anyone needs it. They run it, we should see the duck moves all the way up. Wait a minute. Oh, I forgot something important. Okay, so at the spot where we set the position timer to 0, we're also going to set the Boolean to either true or false. So the way we write that is ducky go places equals not ducky go places. So that way, if it's true, it's going to be set to false. If it's false, it's going to be set to true. And that's how it goes back and forth. Now, when I run this, as we can see, the ducky is going up and down as intended. Yeah, ducky go places. Okay, so does anyone need more time? Yeah, that's okay. So I'll wait on this screen for a little bit longer. Yeah, you can also reverse the timer. I just personally like doing it this way just because, I don't know, personal preference, and it's just another way of doing it. But yeah, you can either do it this way, you can reverse the timer, you know, whatever ends up working. Can I scroll down a bit more? Sure. It's still not working. That's weird. I guess I could do a quick recap too, and maybe you'll be able to see why it's not working. But to start off, we load in the duck model and texture. We set up the camera. We create the duck entity and set its transform, scale, all of that. And then we set these variables here, the original position, new position, the timer variables, and the Boolean. And then once all that's done, down here, we increment the timer with delta time. We reset the timer if it goes above our limit, and we set the Boolean. We calculate the t value by dividing the timer with the time limit. And if the Boolean is true, then it lerps up on the y-axis. Otherwise, if it's false, then it LERPs down. And at the very bottom, we need to remember to update our camera, to recompute the global matrix for the duck entity so that its transform gets updated. And we also need to make sure that we're drawing it so that it actually renders to the screen. Yours is working? Okay, great. It could be that there's like a small mistake or typo somewhere. So maybe like send a screenshot to Samantha and maybe she'll be able to help out. Ducky go places. You made a typo there, but anyways, Ducky go places is right here. It's underneath the timer. Aiden says his is still teleporting. Did you make sure to set the Boolean inside this if statement? When you're LERPing here, are you LERPing from the new position to the original position? Yes, and it's still. See which part, the if statement? So, yeah, so just double check everything. If it's not running as intended, I created duck equal places up here. A lot of times when there are problems like this, it's usually something really, really small. Worst case, you can look at the lecture recording after or send Samantha a screenshot, and afterwards I'll be able to help out too once I'm done talking. And I'm almost close to the end. So if you're still running into issues then I will absolutely be able to help out. You got it? That's perfect. Great. Okay, so now I am gonna continue on. And now what I want to do is we have the duck moving up and down, and that's fantastic. But I also want to change its color just to, you know, add a little more spice. So, like I talked about earlier, the duck does have a material attached to it. And if we actually go to the material class, we see that there's a vec3 called mColor. So the way that it works is this gets multiplied by the duck's texture color. And that, you know, again, if you use Unity, you would probably have an idea as to what this looks like. But yeah, so for the remainder of this tutorial, I want to LERP the duck's color. And does anyone feel brave enough to be a volunteer for the last part and to walk through the rest of the code with me? If not, that's totally fine. Ooh, okay.
Oh, so, okay.
Okay, great. So who am I talking to?
Leo.
Hello. Okay. So Leo, I'm over here. I want to LERP the duck's color. So what variables should I declare first?
So you'd want to declare. So you'd want to declare two vec3s, I want to say almost.
Yep, vec3s. So I'm going to call the first one original color, call, and the original color by default is always white. And to represent that, we write GLM vec3 1 1 1. And what basically for colors, it's represented with RGB. So with position, it's XYZ. With colors, this is R, this is G, this is B, and RGB stands for red, green, blue. Now, Leo, what color do you want the duck to turn into? Do you have any preferences?
Let's make it Neon green.
Neon green. Okay. Well, I think if I do this, we'll get some shade of green. I don't know what kind of neon it'll be. Oh, actually, never mind. Ignore what I've said. RGB. I brain farted for a second, but we're just going to pretend that didn't happen. Why am I getting an error? Oh, duh. New call equals that. Okay, perfect. So we have the original color, we have the new color. Now what?
So we have a new color, and then we call our LERP function our template.
Before we do that, we still have some variables to declare.
Oh, okay. So we want to do our T, which is our.
Even before, oh, sorry, I should clarify. Let's make it so that the color is lerped on its own timer. So on its own timer with its own Boolean. Sorry, I should have clarified. I brain farted twice, forgive me. But with that in mind, what variables would I declare next?
So if we're going to create our own timer, so we're going to want both a start and an end. So we're going to create like our first 0, and then our end, we could have it at whatever color that we want it at. Or how much time, it's the time, right? So however long we want it to be.
And I'll just set it to 5. And now to finish off, we just need the Boolean. Bool, you know what? I'm gonna call it ducky go color. And I'll set it to true. Okay. So now that we have those variables, how are we gonna finish this off?
So now that we have all of our, and if it's going to run if the timer is running independently,
Yep.
we could start by so we're going to start by creating a new if statement, I suppose, or we could actually do it inside that if statement.
A new if statement, that's correct.
Yeah. A new if statement with our variables. So we want to compare the beginning to the end.
Mm-hmm.
So they'd be creating, so the beginning is less than or equal to the end. We make the beginning, the timer equals 0, and then our flip variable, our flip Boolean, we would reverse it.
Timer equals 0, perfect. And then ducky go color. My variable naming conventions are clearly a little questionable, but that's okay. All right. So we do that. Then we
so then after that, we can we create another set of if and else statements with the Boolean as the if parameter or whatever. And then we would
color. I can just copy past this. So I'll do that to save time. So if ducky go color is true or if it's false. And when we call the lerp function, it's still pretty much the same, except we're not lerping the position anymore. And we're not going to be referring to duck entity. We're going to write duck mat because we're using the material, m color, and then we lerp it. Oh, with the original color.
Yeah,
the new color. And then I'll copy past to that. Oh, and we need to calculate a new t value. So I'm going to call that, what am I going to call that? T call equals call timer divided by call time limit. And I'll let you guys catch up. Where is the color thing? Are you referring to where I declared the color variables or? color vec3. Okay, yeah. So that's right up here. Underneath the place where we set all the position stuff, that's where the color stuff is. Oh, you mean in the namespace? So that's just something I wanted to show you guys for context, but there's a material class and it has a color vec3. And that's how you change the material's color. And I'm referring to it down here. Now, if I try running this, and thank you so much, Leo, for being a volunteer. You did fantastic. And thanks for everyone who commented in the chat. But if I try to run this, then shit. So it's changing color, but not the way I intended. Why is that?
You're still using T pause for the color instead
Oh
of
my
T call.
God, you're right. I'm so horrible. Oof. Okay. So T call.
Also, the green is really hard to tell when it changes. Like, I have red, and only
The only
then
reason it's hard
that
for you to
is
see
blue.
green, Jonathan, is because you're colorblind.
I mean, I am colorblind and I can't tell
In the
the
green, specifically. No green, please, thank you.
It's not,
That's why I
it's
have
not meant to be
hot
mean,
pink.
but like it definitely was changing.
Okay, so before we continue, there is one thing we forgot about.
It was. I know it was changing, just not enough.
Yeah, well, we forgot to increment the color timer with delta time. And I guess, again, this shows that a lot of times when something's not working, it's because of something really, really small that we overlook. But luckily we caught that. So now when I run it, any second now, the green is a little bit hard to tell. I mean, you can still see it here. And sometimes that's because of the original texture itself, since it's multiplying with that. And I believe Jonathan mentioned that making it red is a lot more noticeable. And yeah, you're absolutely right. With this particular mesh and with this particular texture, making it red is like super noticeable. So if I run it again, yep. So red is super noticeable. And yeah, again, thank you so much, Leo, for volunteering. Thank you for everyone. Thank you everyone for getting involved. Are any of you guys, can you go back up where you declared the color stuff? Yep. So the color stuff is here. So that's basically the LERP tutorial. You know, we learned how to set up entities. We learned how to load in meshes and all of that. Yeah, don't be scared if you're like overwhelmed by any of this. I swear it gets easier just, you know, with more practice. And if you have any questions, you can always ask me or Samantha through Discord or on email or anything like that. Can you go back to where you create a T call? Yep, it is over here. But yeah, so now that I've taught you guys how to do this, if you go to Canvas, there is actually a tutorial assignment. And for that assignment, and I will pull it up in a sec if you guys want to see it, but you're basically going to load in your own, yeah, we're done the main tutorial activity itself. Like, this is all I wanted to show you guys. The rest of the period will work as like a work period. So like, oh my God, I ordered that awfully. I had classes all day. Anyways, so for the rest of this period, you guys will be working on the activity. And if you have questions or if you run into technical errors, you can just ask me. Yep, I can scroll up a little bit. Like this, is this good? Yeah, okay, perfect. So I will push this very soon. And on Canvas, there will be a tutorial activity for you guys to complete. If I remember correctly, you're gonna have to load in your own GLTF model from the internet and I believe modify some of its properties. I would have to double check, but it should be on there. And yeah. So when will you post this tutorial video? Probably.
You know what? I'll stop the recording right now, and then I'll set it to upload on my internet, so probably in about an hour or so. The activity will be due tomorrow at midnight to account for the fact that you might be having issues with tech and, you know, you guys have had classes, you want to eat dinner, that sort of thing. So the activity will be due tomorrow at midnight. Well, 11:59. I'll stop the recording right now. Sorry to butt in there, Atia.
Oh, that's okay. Someone is saying they can't